During the late 50s and early 60s, America was locked in a battle with the Soviet Union to become the first nation to land a man on the moon.
Listen, Tranquility Base here. The Eagle has landed.
The social and technological strengths of America were put to the ultimate test, and in 1969 we won. And we took that one small step for man that did indeed turn out to be a giant leap for mankind. In today's world, there's been yet another gauntlet thrown down, but this time by China. And today's moon race has evolved to be a race involving emissions and a race to zero emissions.
Ultimately, the race to zero is a race between the United States and China to see who can deploy the most zero-emission transit buses, and it's actually a competition between the two countries.
And one of the best areas to have an impact on zero emissions is mass transportation.
Hydrogen for transportation is something that is rapidly growing. It's started with all of these technologies, cars, buses, trucks, but now it's been ramping up for cars, and we see hydrogen for buses coming to a kind of turning point where buses are becoming more prevalent and transit agencies seem to be more comfortable with hydrogen, and we think that's going to help in the adoption of hydrogen for buses.
We caught up to many transit authority executives at a conference in Canton, Ohio, where the race to zero was discussed.
We're in Canton, Ohio for the North American Fuel Cell Bus Conference. The conference was hosted by the Stark Area Regional Transit Authority, by Kurt Conrad and his team at SARTA, and CTE, Center for Transportation and Environment. The conference was all about bringing people interested in fuel cell buses, fuel cell technology in the transit bus market to a common central location where they can talk about what's going on, what are they doing, and how we can move this technology and this technology specifically in this market, the transit market, forward, and again provide that benefit of zero emission through fuel cell technology for a larger group of people.
If you hit the gas pedal hard enough, the fuel cell will ramp up and provide the power. If you drop off, it'll go into coasting, the fuel cell will drop, we'll take regen power and push it back into the batteries.
The race to zero, mainly waged between the US and China, also has other countries interested.
Well, London has big air quality problems, and the mayor has realised that, and he has two big pledges, one of which is to clean the air up in London. Therefore, transport is something that he can have pretty much direct control over. So it's a massive push to get low emission and zero emission vehicles in London.
And of course, zero emissions is important to a state like Ohio.
Really, Ohio is on the map thanks to an investment that we made more than a decade ago to try to set up the Fuel Cell Coalition in our state, which helped businesses connect with other businesses who are innovating in the industry. It helped to make sure that we attracted investment to Ohio, both private and public investment. And the idea that we could develop the competency to be the place of innovation for fuel cell development.
The U.S. picked up that gauntlet, led by the U.S. Department of Energy. And according to their website, world emissions are forecast to reach around 37 billion tons of carbon dioxide from fossil fuels burning in industrial activity in 2017. Now that's according to results released in the journal Environmental Research Letters and more detailed findings in Earth System Science Data Discussions. The U.S.-China Race to Zero Emissions Challenge aims to promote the development and adoption of innovative zero-emission bus technology and to stimulate demand for zero-emission buses, leading to greater economic growth and reduction in greenhouse gas emissions.
Well, I don't think it matters who wins it, that we all need to be. It's a global challenge, it's a global issue, and the United States is an innovator. I mean, the United States has a history of developing new technologies, and that's our strength, actually. I'm not sure we'll ever be able to compete with the Chinese in terms of manufacturing, but like the Ohio Secretary of State who just spoke, in your state, in the state of Ohio, is ripe for innovation and for being a leader in that regard.
If you look, the Chinese consumption, so to speak, is what's really driving a lot of the innovation and a lot of the research. I mean, it seems like everywhere you go in this field now, there's a very large Chinese presence. And you know, the government is putting lots and lots of money into making this the energy and zero emissions and a very high priority.
It certainly is. That competition from overseas is just helping General Motors with new ideas, new sources of technology, new concepts that we can combine into our work.
As far as global competition, we all have a common interest here, whether it's Chinese, whether it's Japanese, whether it's Asia or Europe or South America. We have a challenge to protect our environment, to protect our planet. We all need to be involved in this.
And that's why there's such a focus on mass transportation emissions. Through this collaborative and friendly competition, the Race to Zero Emissions encourages transit agencies to incorporate new generations of advanced, non-polluting, zero-emission buses into their fleets and onto the streets in the United States and China. Stagecoaches, canal boats, railroads, aircrafts, and buses have been the workhorses for moving people from one location to another. And since we are talking about buses, how has that mode of transportation developed?
If you really look back at the first vehicle that was really put together, even here in Northeast Ohio in the 1880s, it was electrification. Those streetcars were electrified. And then about the 1890s, early part of the century, diesel engines were invented. And so that's really where a lot of the heavy vehicles started operating. And then we here in this industry, in about the 1920s, 1930s, started moving from the streetcar to rubber-tired diesel-powered buses. And that basically was the mainstay of transportation. And in probably about 2010, fuel cell buses started coming around. Really, with the biggest fleet in North America at that time was at Whistler for the Winter Olympics that they held in Canada in 2010. They had 20 fuel cell buses there.
What are non-polluting zero-emission buses and what powers them? Diesel, gas, natural gas, electricity, a combination of all, or fuel cells?
Well, first of all, I think, bar none, electric drive propulsion is our future. And it is our future because it's much more efficient from an energy standpoint. It's much more enjoyable to operate an electric drive vehicle, whether you're a consumer with a car or light duty vehicle or a bus or truck operation. And it has inherent with it are cheaper means of maintenance and operation. So I do think it's between transitioning from internal combustion engine to electric drive.
What a ZEV is a zero-emission bus. And what that means that there's absolutely no emissions that come out of the bus itself. So there's no, like a normal diesel bus or a natural gas bus has some exhaust that comes out, whereas a zero-emission bus, either battery electric or fuel cell, has zero emission when it operates whatsoever. So a battery bus just operates off the battery like any other battery electric car would, and a fuel cell bus then operates off of hydrogen, and the only thing comes out of the tailpipe, so to speak, is water.
We've all heard of fuel cells, but what are they? And how does it compare to a diesel engine? And who do you think would win in a drag race? But first, what is a fuel cell and how does it work?
Hydrogen and oxygen enter opposite sides of the fuel cell. The hydrogen molecule separates into protons, which move through the cell, and electrons, which follow an external circuit delivering electricity to an electric motor. They reunite to produce only two byproducts, heat and clean water, pure enough to drink.
A fuel cell is a device that converts hydrogen into electricity, and it does it in a very efficient way. The only byproduct that comes out of it is water vapor, and it allows us to power electric vehicles and other applications where we need this zero emissions technology.
You've heard talk of fuel cells for years, so who did the most to advance the development of fuel cells?
So if you look at the history of fuel cells, they were literally invented in about 1858. So they've been around for a long time. The predominant history of the current configuration we have now is NASA really started using fuel cells in the space program in the 1950s. And so that was the predominant fuel source on the space shuttle and all the rockets.
So, how does a diesel engine compare with a fuel cell engine in a drag race?
So specifically related to our Class A truck, we call that our Project Portal. We're really excited about that technology because it allows us to demonstrate that you can take the fuel cell systems from the light duty vehicle, the Mirai, and put those in a Class A truck and operate that Class A truck, and you can have the same or better performance than the diesel. Today I was able to show a video where we show an acceleration of the two trucks weighted at the same load, and what you'll see is the fuel cell vehicle well accelerates the conventional diesel truck. And that's because there's no transmission gears to shift through. You get all that peak power right away from the electric drive. So it's a very different and exciting experience for the driver.
We see what those results were, but what are the economic advantages of fuel cells?
Well, I think the one thing you're seeing with a fuel cell specifically, the size of the fuel cell has decreased by about half, and the power density that comes out of the fuel cell has increased by about 60% out of the last couple of iterations. We're actually working with Ballard on the next generation of fuel cell, which actually will have less precious metals in them because the active layer right now uses platinum, and so they actually have got it now where they use a silicon base. So you're seeing that cost curve come down quite dramatically, along with the efficiency increasing quite dramatically.
What are the challenges for zero-emission buses?
Really, I think is just getting, we as an industry, setting the standards and what the expectations are from the manufacturers. I think that's a big deal, and having that consistent demand, so to speak, from our sector is really what needs to happen. And I think it was said earlier today that we've moved beyond the 1 and 2 bus orders, and where you're whittling each bus by itself, to now we've kind of got a line going where you're producing a bus, so to speak, with that order. And so I think the volumes is just the big thing is that we need to work towards is really those volumes.
When the Russians launched Sputnik on October 4th, 1957, it was the opening shot in the space race. And yes, they beat us. So we knuckled down and we did it. And we can do it again in this race to zero. And in doing so, we'll be able to keep striving for that giant leap for mankind, led once again by the United States of America.
I do think that one of the great things that we're seeing in areas, especially like in California where I'm based out of, is just the commitment by the government to really support these technologies. And I think that's one of the key pieces. It's really going to be a joint effort with everyone to achieve a sustainable system. We can't do it just the automaker. We can't do it just the fuel provider. It really needs to be an all-inclusive effort together to achieve a sustainable system.
When you're kind of a leader like we are in this technology, that people get inspired, so to speak, to work on it. They want to be involved in something that's kind of industry setting. So I think that with the outreach education we've done and being a part of a cutting edge project really gets people excited.
The AC Transit has always been a very forward-thinking organization. We're very fortunate that we have an executive team that supports the deployment of zero-emission technology, clean technology, and we're not doing that just because we want to be on the forefront and earn credit. We're doing it because we really want to be good stewards of the communities that we serve, and we want to do it in a responsible manner.
But if the USA does not beat China in the latest race to zero emissions, and they're able to nudge us out of the initial competition, it's actually mankind who wins, with a cleaner, healthier world environment led by mass transportation.